Hey, if you're prepping for a networking certification, you are in exactly the right place. We are about to break down the three pillars of any modern data center, giving you the clear architectural diagrams you need to really nail your exam.
So here's our game plan. We're going to build the big picture one layer at a time. We'll kick things off with server virtualization. That's the tech that makes all this other cool stuff possible. Then we'll stack the cloud models on top, bring in the intelligence with software-defined networking, and finally, tie it all together into one unified picture.
All right, first up, virtualization. You have to think of this as the bedrock of modern IT. It's the fundamental technology that lets us do way more with way less, and it completely changed how we think about server hardware.
So what is server virtualization really? Well, at its core, it's the magic of running multiple, completely independent virtual machines, and each one has its own operating system on just one physical server. This idea of carving up one big machine into many smaller, logical ones, it's absolutely crucial for the kind of efficiency and scale that we need today.
Now, this slide is key because it shows the two ways you can do this. On the left, you've got a Type 1 or bare metal hypervisor. See how it sits right on top of the hardware? Now compare that to Type 2 on the right, which is really just an application that runs on a regular operating system. That direct access to the hardware is why Type 1 is so much faster and more secure, and it's why it is the standard for any serious production environment.
And you know, this isn't just a neat technical trick, the operational benefits are huge. We're talking about server consolidation, where you can replace 10 or more physical servers with just one. You get fantastic isolation, so if one VM crashes, it doesn't take anyone else down with it. And features like live migration, literally moving a running computer from one piece of hardware to another with zero downtime, that's a total game changer for businesses.
Okay, so we've got our virtualized foundation. Now let's build on top of it with the cloud's as-a-service models. This is where we stop thinking about managing individual servers and start thinking about consuming services.
This stack shows the fundamental trade-off in cloud computing perfectly. Down at the bottom with infrastructure as a service, or IaaS, you still manage a lot. The OS, the runtime, your app, everything above the hardware. Now, move up to platform as a service, PaaS. The provider takes care of the OS and runtime for you, so you can just focus on your code. And then at the very top, you've got software as a service, or SaaS, where the provider manages literally everything. The rule is simple. The higher you go up the stack, the more convenient it gets, but the less control you have.
And to make that trade-off super clear, let's use a simple and kind of famous analogy that everyone can get behind.
I love this. So on-premise, that's you making a pizza completely from scratch. You own the kitchen, you buy the ingredients, the whole shebang. IaaS is like a take-and-bake pizza. They give you the core components, but you're still using your own oven at home. PaaS is pizza delivery. It shows up hot and ready, you just have to provide the table and drinks. And SaaS, that's just dining out. You show up, you eat, you leave. The restaurant handles everything else. It's all about how much of the work you want to outsource.
It's also really important to remember these services can be delivered in 4 different ways. You've got the big public clouds like AWS or Azure that anyone can use. You have a private cloud, which is dedicated to just one company. A hybrid cloud mixes both of those. And finally, a community cloud, which is shared by a few organizations that have similar needs. The one you choose really just depends on your security, cost, and control requirements.
Okay, so we have this massive virtualized cloud. But how in the world do we manage the super complex, always changing network that ties it all together? Well, that's where we meet the brain of the modern network.
See, in the old days, every single switch and router had its own little brain, the control plane, and its own muscles, the data plane, all bundled together in one box. Each device made its own decisions, and that's just way too inefficient and clunky to manage at cloud scale. This whole management nightmare led to a really simple but powerful question. What if we could pull the brain out of every device and separate it from the brawn? That single idea, that is the core of software-defined networking.
And here's how it works. SDN splits the network into 3 distinct layers. At the bottom, you have the infrastructure layer. This is just the brawn. Simple switches that do one thing, forward packets. All the intelligence gets ripped out and centralized into the control layer, where a single SDN controller acts as the brain for the entire network. Then, at the very top, the application layer lets us write programs to tell the brain what we want the network to do. It's a huge shift.
And all this communication happens through 2 kinds of APIs. Just think of it this way. The northbound API is for telling the network what you want. It's your intent. You tell the controller, hey, I need a secure path for my payment data. The southbound API is for how to do it. That's the controller sending detailed, low-level instructions down to the switches to actually build that path. So northbound is for intent, southbound is for instruction.
All right, let's do this. Let's put all the pieces of the puzzle together and see how virtualization, cloud, and SDN create one big, unified architecture.
Okay, if you're going to remember one single diagram for your exam, this is it. This is the money shot. It shows the whole story. At the bottom, you have a physical server. On top of that, a Type 1 hypervisor is creating a bunch of virtual machines. Those VMs are being delivered to a user as an IaaS cloud service, and the entire network connecting all of those VMs is being intelligently and dynamically managed by that central SDN controller. See how it all fits? Virtualization creates the resources, cloud delivers them as a service, and SDN manages the connections.
All right, time for a quick-fire review. These are the key takeaways. For virtualization, just burn this into your brain. Type 1 is bare metal. For cloud, know what you manage. In IaaS, you manage the OS. PaaS, you manage the code. SaaS, you just manage your data. For SDN, the big idea is decoupling the brain from the brawn. And one last thing, VXLAN. In these huge cloud environments, the old VLAN technology maxes out at around 4,000 networks. That's nothing. VXLAN blows that away, allowing for over 16 million separate network segments, which is absolutely essential for this to work at scale.
So this huge shift from hardware to software, it just opens up so many incredible possibilities. Our networks are now basically programmable, just like a piece of software. It really makes you wonder, what's the next big leap going to be? What happens when we apply even more automation and AI to this new intelligent infrastructure?